Hello, today we are going to see the implementation of a deadlock avoidance algorithm. So in this we will see how to write a program to simulate the banker's algorithm for a purpose of a deadlock avoidance using C or C++ or Python. So in this code first I have given a header file. So inside this int main I have given a integer r, n and I, j, k and sum is equals to 0, c equals to 0, x is equals to 0 and y equals to 0. Then here it will print the enter the total number of processes and it will scan for the user, and here then it will ask to print the enter the total number of resources. Then it will scan it will scan from the user. Then here int a of r, and here int w of r, and here int s of n, and here int flag of n, and here all of n and r array, then max of array n and r, and the r need of n and r, and the work n of and here r. Then here I have given a for loop. So inside this for loop I have given I is equals to 0, I less than n, and I increment. Then it will print the enter the details for a p percentage d, and here it will print the enter the location. So here in this for loop, here j equals to 0, j less than r, and j increment, and it will scan from the user. Then it will ask to enter the max, and here in this for loop, here is j equals to 0, j less than r, and j increment, and here scan from the user, which is ampersand max and of I, array of I and j. Then here flag of I equals to 0. Then here it will print the then here it will print the enter the total resources, and here in this for loop, inside this for loop I equals to 0, I less than r, and I increment, and here it will scan from the user, and here in this for loop here I have given I equals to 0, I less than r, and I increment, and here for j equals to 0 and j less than n and j increment, and here the sum is equals to sum plus all of array of j and array of I. Then w of I equals to a of I minus sum, then sum is equals to 0. Then here in this for loop, I equals to 0, I less than n, and I increment, and here j equals to 0, j less than r, and j increment. Here r needed of I of j equals to max of I of j minus all of I of j. Then here it's n, and here the for in j equals to 0, g less than n, and g increment, and here inside this I'm using the while loop. So here in this while loop, the flag of g not equal to 1, and here in this for loop I equals to 0, I less than n, I increment, and here the j equals to 0, j less than r, and j increment. Here if the flag of I is not equal to 1, then if in this inside this if r needed of I of j is less than or equals to w of j c plus plus, then here the if c equal to r, then here s of x is equals to I, then x increment, and here k equals to 0. Then and here in this while loop, the k I not equals to r, and the w of k equals to w of k plus all of I of k. Then the work of I of k equal to w of k, then k increment. Then here a y plus plus, the flag of I equals to 1 and c equals to 0, and here else c equals to 0. Then here it will print the save sequence. Say save sequence is and here in this for loop I equals to 0, I less than n, and I increment. Here it will print the percentage d and s of I. Then here it will print the process, new tab, and allocation, max, work, and need. And here the inside this for loop I equals to 0, I less than n, and I increment. Then here it will print the p percentage d and comma I. Then here in this for loop j equals to 0, j less than r, and j increment, and here it will print the percentage d comma all of I of j. Then here it will print the new tab. Then here inside this uh, for for loop j equals to 0, j less than r, and j increment. Then here it will print the percentage t, the max of I of j. Then here it will print the new tab. Then here inside this for loop j equals to 0, then j less than r, and j increment, and it will print the percentage d work of I of j. Then here it will print the new tab. Then for inside this for loop j equals to 0, and j less than r, and j increment, and it will print the percentage d r need of I of j. Then now we'll run the code. Then it is asking to enter the total number of processes. So here we'll enter the total number of processes. Here I will give a 5. Then it is asking to enter the total number of resources. I will give 3. Then enter the details for a P0. Then it is asking to enter the allocation. So then I will give 0. Then it is asking to enter the max. I will give. Then it is asking to enter the details for a P1. Then here it is asking to enter the allocation. So here I will give. Then the max I will give. Then here details for a P2. Then the allocation I will give. Then max I will give. Then for the P3 I will give 2 1 1. Then max I will give. And the P4 for the allocation. For allocation I will give. Then max then here it is asking to enter the total resources. I will give. Then here it has printed the process allocation, max, work, and need. So which the allocation I have given in a P0 is 0 1 1 0, and the max is 753, and the work 532, and need 743. Here I have then here it has printed. Then P1 it has printed 200, and max 322, and 743, and 122. And for the P2 302, and 902, and 754, 745, and 600 it has printed. And for the P3 211, and 422, and for the work it has printed a 5 755, and need it has printed a 211, and P4 002, and max it has printed a 533, and here the work it has printed a 1057, and need it has printed a 531. So the program is executed successfully. Thank you.